All right, welcome to The Explainer. Today, we're diving into a really fundamental shift in how we actually build software. We're going to be looking at how Claude Code's multi-agent system is just completely transforming software engineering workflows from the ground up. Because look, we aren't just talking about a slightly smarter autocomplete anymore, right? We are talking about an orchestrated, parallel intelligence that runs right inside your terminal.
So let me pose a scenario. How do you refactor 50,000 lines of legacy code without completely breaking production? It's a massive, massive engineering challenge. I mean, if you've ever tried to paste a gigantic chunk of old, tangled code into a standard AI chat window and just asked it to make this cleaner, well, you know exactly what happens. It spits out this beautiful, highly modular code that absolutely does not work. And then what? You spend the next 2 days untangling all its mistakes? Traditional single-prompt AI tools they fail at this scale. They lose the plot entirely.
And there's an actual term for why they fail. It's called context rot. Essentially, context rot is the degradation of an AI's performance when you overload a single context window. Think about it. When you force one AI agent to plan the architecture, write the implementation, remember all your error handling, and review the code all at the exact same time, its cognitive space just gets completely polluted. The original instructions fade away, hallucinations start creeping in, and the AI starts making these really wild assumptions. It's basically the AI equivalent of trying to juggle flaming swords while solving a Rubik's Cube. It's just too much.
So what's the fix here? Well, the fix is Claude Code. It's this high-tech power tool that operates natively in your environment. It can interact directly with GitHub issues, search through your codebase, and brainstorm fixes right there from the command line. So it's not just another web chatbot you have to tab over to. It's a true agentic coding environment that uses specialized subagents to bypass that context rot completely. The contrast between the old way and this new way is pretty stark. On one side, you've got the single-agent workflow. It's slow, it's prone to hallucinating bugs, and it suffers from massive context pollution. But on the flip side, multi-agent workflows. They are fast, verified, running in parallel, and operating with completely isolated focus. Because true agentic coding really requires separating out the planning, the coding, and the reviewing into their own dedicated cognitive spaces. So instead of one totally overwhelmed AI, Claude Code unleashes these specialized parallel subagents. It's like a highly trained crew. You've got an investigator that safely explores your codebase without actually writing a single thing. It passes its findings over to an implementer, whose only job is to write the code. And crucially, the implementer is isolated from the test-writing logic, so it can't cheat or overfit the tests. Then, a reviewer steps in to double-check assumptions and look for security flaws, all while an orchestrator manages the handoffs. Every single one of these subagents runs in complete isolation. They staying hyper-focused on their one specific job. And you can actually take this parallelism to the absolute limit. You can use Git work trees to run multiple independent Claude sessions simultaneously, which is crazy. You could literally have one Claude instance refactoring your entire authentication system in one folder, while a totally separate instance is building out a data visualization component in another. They're running at full speed concurrently. No waiting around on sequential tasks, and definitely no merge conflicts slowing the AI down.
To keep all this chaos organized, the system uses something called the Verified Multi-Agent Orchestration Architecture, or VMAO for short. It works in a loop. First, the orchestrator plans by taking a massive problem and breaking it down into a directed acyclic graph, or a DAG. Second, it executes, firing off those specialized subagents we just talked about, in parallel. Third, the AI dynamically verifies its own completeness. And finally, if it realizes it missed an edge case, it adaptively replans and retries. That loop right there is exactly how this system thinks.
Now, the really crucial point here is the quality filter. When a developer opens a pull request, the system doesn't just run one quick check. Multiple independent AI agents examine the code, and then, and honestly, this is the magic part, they cross-verify each other's findings. If one agent flags a bug, another agent double-checks to see if it's actually real or just a hallucination. This systematic cross-verification rigorously filters out false positives before a human ever even has to look at them.
And because of that rigorous cross-verification, the final output you get is incredibly refined. You know how annoying it is to sift through hundreds of noisy, totally irrelevant linter warnings? Yeah, that's gone. Instead, the developer gets a clean, actionable overview comment right on the pull request. The remaining genuine issues are intelligently ranked by severity, and they come with specific inline explanations attached directly to the problematic lines of code. It just fundamentally respects your time.
Which brings us to this absolutely massive number, 200%. This orchestrated multi-agent factory approach isn't just some neat conceptual trick. It's delivering a massive 200 to 300%, so a 2 to 3x boost in overall engineering productivity. When you eliminate that context rot, parallelize the heavy lifting, and automatically filter out the false positives, your output is literally going to skyrocket.
Hey, really quick, if you're finding this breakdown of multi-agent workflows valuable, make sure to hit that subscribe button right now. We are constantly dropping deep dive explainers just like this one on the absolute most cutting-edge AI engineering tools out there, and you definitely won't want to miss what we cover next.
Okay, let's ground that 200% metric in reality for a second. Remember that nightmare scenario from the beginning about refactoring 50,000 lines of code? Well, check out this real quote from a developer who used this exact workflow on a massive legacy Django monolith. They said, "It took me 3 weeks with this workflow. I'd estimate 2 to 3 months minimum without it." Just by using subagents to isolate the planning, implementation, and review phases, they kept the AI completely on rails. They shrank months of grueling work down into mere weeks. Moving right along to the safeguard human-in-the-loop control. Because yes, we've seen the incredible speed, but now we need to see how we actually keep this thing safe and strictly under control. So Claude Code is intentionally designed with a very conservative approach to safety. By default, it will actually stop and ask you for permission before executing anything that could modify your system, like writing files or running bash commands. But to make sure you maintain your momentum and aren't just clicking yes all day, you can configure explicit permission rules. You can safely allow list specific commands like running your test suite or your linter automatically. You are always in the driver's seat. The whole system is brilliantly structured around these specific human touchpoints. As the developer, you step in at the critical moments. You approve the initial execution plan before any code is actually written. You manage those explicit tool allow lists. You grant the permissions for the big, significant actions like a Git push. And of course, you do the final human pull request review. So this absolutely proves that this isn't some unchecked runaway AI. It's a highly monitored collaborator. If we had to summarize the core philosophy of this entire workflow, it boils down to this. The AI proposes, verifies, and plans, but the human orchestrates and approves. The role of the human developer is fundamentally shifting here. You're transforming from a line-by-line typist into an elite system orchestrator, guiding this entire team of highly specialized parallel digital workers.
And that leaves us with a pretty fascinating question to end on. If we now have specialized AI agents autonomously writing code and a totally separate team of AI verification agents rigorously cross-verifying that code in parallel to filter out false positives, is the era of the human code reviewer coming to an end, or are we just totally redefining what it even means to review code? It's a provocative thought for sure, and I highly encourage you to ponder how this is going to shift your own workflows. Thank you so much for joining me on this explainer, and I'll catch you in the next one.